All right, everybody. Happy Friday. Woo!
Ooh, finally. It's finally Friday.
Like, did we have, was Monday a holiday?
I don't know.
This feels
No, I
like
don't
the
think so.
longest week of my life.
Yeah, it's been a long week. It feels like it's been 2 weeks this week.
Yes. I don't know what's going on, but this has been a very, very, very long week, and I think it was indicated in our team Slack earlier today that I had completely lost track of space and time. But anyways, hello everyone. I am Chris Short. I am the executive producer of our live streaming efforts here at OpenShift. This is my teammate Christian Hernandez. I will let him introduce himself. He is on the technical marketing team with me.
Yeah. So I think Chris, he pretty much summed it up. So
no, but you're the expert.
Yeah,
so
technical marketing, right?
Yeah, you're the expert on what exactly?
Yeah, technical marketing. Yeah. So and I'm here to talk about subscriptions, right? Subscription management. Right. In terms of OpenShift, right? Which is kind of also Amy's here.
I was gonna handle that in a second.
She had to step out and do actual work.
Like her phone actually rang as we were about to go live. Yeah. So that's why we were kind of take it. It's more important than
take it. It's more more important.
Yeah, it was way more important. But you may notice at the bottom of our screen right now we have a banner. It's a follower goal. Yes. We want to have 1,000 followers on Twitch. So head to twitch.tv/Red Hat OpenShift and hit the little heart button there.
There we go.
We need 1,000 followers by the end of June.
It takes very little. That's the goal, right? It takes very little effort.
Low effort, high gain though, right?
High gain for us. So
yeah. It's a big deal for us. So
if you haven't already, make Chris Short happy. Don't make him sad.
Make Chris Short happy. I need to go get a site with shirts now.
Yeah, they say shirts and hats and made. You know what's we're just talking about Amy stepping away. Well, you know what's funny? I just realized that you, Chris, you have extensive background in Ansible and DevOps and all of that, and I'm on the OpenShift side, and Amy's on the OpenStack side. So I think between the three of us, we can actually.
Holy smokes! I didn't realize
we have a lot of expertise on this.
There's a lot of brain trust here.
There's a lot. Exactly.
There's gonna be a lot of chat now.
yeah. So it's back to the topic at hand, right? We're talking about subscriptions and in terms of OpenShift, and it's funny, right? Because subscriptions had to kind of evolve with OpenShift because of how just the nature, right, of cloud computing and cloud native computing, and being able to scale, right, in on demand, right? So we introduced with OpenShift 4 the ideas of machine sets and auto scaling, right? Whereas if you're starting to consume your nodes are starting to consume a lot of workloads. Amy, she's here. Hey, Amy, do you want to introduce yourself here?
Yeah.
We're doing this off the cuff. So.
Okay. I'm Amy Marrich. I'm on the Cloud Platforms Business Unit technical marketing team, along with Chris and Christian, and my specialty is OpenStack. And I'm the new member of the team, so I have lots of questions.
Yeah, exactly. Yeah.
So I have lots of questions too, and I'm not a new member of the team. So,
So Amy, I was just explaining how the subscription model kind of doesn't really fit into what OpenShift's designed for, right? So, you usually have, you have a subscription and you consume that subscription when you're running something like RHEL, right? So that's very simple, right? So you have a server. 1-to-1, right? So you have a server, and you install RHEL on it, and you install your workload, and it's very something you can plan for, right? You can plan for, having more servers or installing a server, with the introduction of the whole Kubernetes, cloud native, all that thing, leveraging the cloud to dynamically scale your cluster, right? Depending on the workload. and the introduction of machine sets with OpenShift 4 and how you can automatically scale. So it's kind of the subscription model had to have been tweaked, right? So it doesn't really exactly fit into OpenShift, because on OpenShift you're dynamically scaling, right? It's like,
it's pods. It's processes.
Yeah, it's pods, processes, right? And then and in there, how do you how do you develop a subscription model for it? So I think one of the cool things that we did with OpenShift 4 is that you can install it, you can get up and running, and then you have a 60-day trial. Of OpenShift as soon as you install it, right?
Right. So you can there's no license barrier to entry kind of deal.
Yeah, correct. So you have you can go to developers.redhat.com to sign up for a developer account, absolutely free, and then you're able to get a access to install OpenShift, and then you get a 60-day subscription. So
what happens after the 60 days?
So after the 60 days,
we send out people to hunt you down. No, I'm kidding.
Your entire workload gets deleted. There's a cron job. That checks the time.
It's a cron job.
It's a cron job.
RM-RF/.
It doesn't start figuring out how many machines you have in your cluster, so it can help you figure out what subscription you actually need at that point.
Yeah. So
let's start at the beginning, right? Like we kind of jumped in at the middle here, right? And
I jump in feet first. Chris,
and Christian goes in, and like, so we have like that physical subscription model, right? So talk about that, right? Like sockets, cores, threads, that kind of stuff, right?
Yeah,
like talk to me about that.
So we have the socket-based subscription, right? And I'm just talking just in general at Red Hat, right? I'm talking So now just to be very clear,
Red Hat high level, yeah.
Red Hat high level, right? There is a socket-based subscription model, right? So whereas you have the actual number of physical processors, right? So we're talking socket-based. So I have a CPU, right? Regardless of what that CPU is, that's a socket. Essentially, cool. You can think about it as, plugging in something. That's a socket, right? You have two physical, right? So we, most servers have two sockets, one or two sockets, right?
Right.
And then we have the idea of cores, right? How many cores are in per socket, right?
We didn't used to have this problem.
That used to never been a problem, right? You used to have
back in the day, back in my day.
Yeah,
back in my day, we used to have this model kind of for enterprise databases.
Right.
How many cores were you going to be
running? How
many
cores did you have? Yeah.
So, but like that, it never used to be a problem because you had a socket, right? So you had because it was just one processor,
one socket, one core.
Yeah, exactly. Yeah. You just have however many sockets you have. That's how many processors you had. So then they have the idea of cores, right? So then you have the idea of like, okay, you have one physical socket, but it'll appear as two CPUs, right? Two independent CPUs doing independent things.
If we want to go even deeper into like the silicon layer, I can talk about that. But
So if there's any, we don't need to. But if there's questions,
if you want to talk about silicon, we can.
We can, we can get really deep.
It's here, right? Like I've.
This is why we have the wide brain trust, right?
Right, like I've been in chip fabs. I know all about that. So let's
build the server.
But keep going. Yeah.
So there's actually a lot of great questions here. They're talking about infra nodes. So this is like later in the conversation, but we're
but let's get to infra nodes quickly. Yeah.
We will get to that. And then we have Intel. Right, I believe came up with hyperthreading. I think it was Intel. Someone correct me if I'm wrong.
Yeah, Intel was hyperthreading.
I think it was, yeah.
Came up with the idea of hyperthreading, right? Where you have, so now you have the idea of like each core now looks like two, right? So then you have, which actually if you haven't been paying attention in the past 2-3 years, it introduces a lot of problems in terms of security. But
yeah. Great revolutionary technology. Wait, I can have one piece of thing and it actually looks like 2 cores, and then then it got to the point. Then it got to the point.
You can even further slice it, right?
Right. So then they got to the point where it's like, wait, we can actually fit these chips. We can fit more chips on one piece of silicon. So that's when it got really weird.
Yeah, exactly. Yeah, it got really weird. So for a while there, we've had on OpenShift, we had a socket-based and a core-based subscription model, right? So kind of like the idea of like, oh hey, meltdown. Someone said meltdown. Yeah, that was exactly that was bad times. Where everyone had to disable hyperthreading.
And reboot all your clouds.
Yeah, exactly.
Exactly. I remember getting emails from every cloud provider. You will be affected at this time as we move workloads around to reboot.
Yeah, we're moving workloads around.
Literally, AWS had to reboot every hypervisor in every cloud.
Yep, and
every cloud provider had to do that pretty much.
Yeah, it was bad times. It wasn't happy for anyone.
No.
So we have.
Anyways, nothing. Yeah, go ahead.
Bad times. Yeah, we could talk about bad times all day.
No. Subscriptions. So we have sockets. We have cores.
So we have sockets, and so that the idea is that you can run. You just count how many sockets you have, and for those that want to do a socket. So basically, if people want to do OpenShift on bare metal, they had a one pricing scheme. Where the socket-based pricing, I think for anything, is pretty high. Only because it just needs to be. Naturally, right. You can
have 96 core.
Right.
Exactly. I can have
96 core single socket machines.
Yeah, exactly. So I can run a lot of workload on that. So it naturally fit into that. But what we found was that not a lot of people were actually consuming that, because we're in an age where pretty much everything's virtualized. Like there's, if you're talking about like bare metal things like virtualization, things like OpenStack go on actual physical hardware, and then you just use it as a normalizing. I always like to think of things at like a high level, right? So like you have commodity hardware that then you put a virtualization layer on top of it, and people were just using virtualization. So we actually just switched to a core-based, right? So we have core-based subscriptions, right? So we have core-based subscriptions, but then that also, we talked about Intel, we talked about hyperthreading. Well, how does hyperthreading come into play, right? So just to level set, right? One subscription of OpenShift covers 2 cores.
Okay.
Simple.
Done.
Right. So if I hyperthread and I have 2 and a 4, we're going to up the price based on that.
So yes and no, right? So so you have a 2-core subscription. One subscription covers 2 cores, but what about hyperthreading, right? What about virtualization, right? So virtualization, you can map things out however you want, right? In the you can go there. It's like, I want to emulate, 1 socket, 1 core, but like 12 threads, right? Like how do you account for those sorts of things, right? So in general, we're talking 1 subscription equals 2 cores or 4 virtual CPUs.
Okay.
Okay. Wait. Slow down there.
Yeah. Okay. No, so I'm going to pause there.
Okay. So there's a caveat, right? Like you get 2 cores right off the bat, right? Like 1 sub of OpenShift, 2 cores, right?
2 cores. Yes.
But now if I go to 8 cores, I need 4 subs.
You need 4 subs.
Okay.
Correct.
How do I get charged for that if I'm dynamically scaling my stuff on AWS? right?
Yeah. So there is. So we give you a window,
right,
to subscribe, right?
okay.
So it's
So it's like a max and a min kind of thing.
yeah, kind of like a max and a min sort of thing. So we give you a time that you're able to run that burstable workload.
Okay.
Right. So similar to the idea of the 60-day subscription when you install it, you kind of get like a trial subscription. Basically,
when we say trial subscription, if you install OpenShift, you have all the bits and pieces, right? It's not like you're missing something, right? Like if there's no like, oh, here's the stripped down, trial subscription version. It's the full thing, no matter what. Like every time you install OpenShift, it's a full OpenShift, right? Unless you install
No, you
OpenShift Kubernetes engine or something else, right? So a whole other ballgame. But
so and that's kind of the thing with Red Hat is kind of weird. Like we don't have so someone made a joke that said, we're the first $1 billion company that made it by selling free software, right? So we don't have like a license, right? There's no license. This stuff is like free, essentially, right? Like you can install
we glue it together. We provide the security and support and the testing and everything else.
Yeah,
and,
so
we bake in the knowledge, but
we gotta come up with that construct of subscription because is what you're getting is patches and.
We have to pay these people that are doing all this work.
Yeah, exactly. Yeah.
So you get let me patches, ask a worst case scenario question.
All right.
Oh boy, here we go. We're going way deep now.
Well, Black Friday.
Yeah.
You realize you're being hit and you're only going to have those extra cores and all that scaling for a couple days. It probably isn't going to hit any timeline, right?
Correct.
Yeah. Right. Yeah.
So that's a good thing. This is a good thing.
You could spin up a week in advance. You could spin up multiple clusters, and
as long as you keep it within our time frame.
Yeah. So it's so for those nodes you have the 60-day, or I don't think it's 60 days. So people don't.
Yeah, I would imagine it's less.
I don't think we give away 400 virtual machines for free somehow.
Yeah. Right? So it's kind of like you get a trial. So I'm just comparing it to the 60 days trial subscription. For those, you'll get a trial subscription. So it's essentially,
It's not,
so essentially, Amy, you're right.
It's not 60 days.
It's not 60 days. But you get some trial subscriptions with
it. And as long as you keep your massive scaling within those days. Now, when you get closer to Christmas and all that, of course, you're going to have all that extra scaled hardware and infrastructure for longer, and that's when you would probably get hit. But if you're only doing it for a really quick weekend, you probably wouldn't.
You're not, quote, getting hit. You're just paying,
right,
what you're using, right? So, every deal is different at Red Hat, right? Like, there's no, standard, everybody buys the same thing, right? There's no, oh, yeah, everybody buys Rel and Quay and OpenShift done, right? Like, it's not like that. Everybody has some different thing. So there's no perfect example to show here. So we're kind of just going through the motions of, poking things and saying, how does this work in this scenario and that scenario? So that's why we're not showing. I mean, we have a doc Chris can show, but it's not like we have some
written in stone,
concrete,
this is what you have.
Stone, OpenShift, this is everything you get. Yes, we have, that initial layer for the dev, but not necessarily for the entire enterprise.
Yeah. Well, yeah. Well, and also it's just if I can go off on a little tangent here, what I really hope they do one day, but I don't make the decisions.
Oh boy.
I don't make the decisions at Red Hat. So unfortunately, what I hope they do one day is kind of similar to networking circuits, right? Like MPLS circuits. As long as you stay within the 90th percentile.
The 95th percentile. Yeah.
Yeah, exactly. It's you can burst and go whatever.
Right.
So you pay for
your 95th percentile of usage.
Yeah, and as long as
that
you
would
stay
be cool. Yeah.
For
like,
me, that makes
and
that
every
makes,
month,
yeah.
every month, yes, it could be different, but it's based off what you're actually using, right? Like,
yeah.
And it's averaged to the 95th percentile for, so that you get the burst,
Yeah,
you get the lull.
You get the lull, yeah.
Yeah. So, yeah.
Okay, quick question from the chat.
Yeah, go ahead, Amy.
Where are these subscription docs? It is never clear and easy to keep up with.
Okay, Christian, here's your cue.
Wait, so the subscription doc. So the docs for depends. Are you Red Hatter or not? Because I can send you if you're Red Hatter, you can email me and I can send you the internal links. So
external.
Yeah. So if external,
this is to the world.
Yeah. So to the but to the world, that would be on docs.openshift.com. I mean, really, it's really as simple as
let me see.
One subscription covers 2 cores. So let's see if we can find it. This is a good.
Like share your screen and like let's searching the docs is something we do on this show because it's important for y'all to have the right info.
Hold on, let me see here. Desktop 3. So here, I can either give you a fish or teach you to fish, right?
Increase your font size, please.
Oh yes.
Sorry.
No. This is, we can go like this big. How big do you want it?
That's a little big.
Let's go.
That's good.
That's good. Okay.
I think so. Yeah.
All right. So let's go to 4.4.
All right. So we are on docs.openshift.com. 4.4's latest version.
Yeah. I never liked our search, but let's try it anyways.
All right.
Operator
installing Knative being the first result when you search for
subscriptions
probably
it's probably not what you want.
No. You don't have this.
OpenShift Kubernetes engine is probably something I do want to cover.
There was one about RHEL subscriptions on the very bottom of that search.
Yeah, so
RHEL, that's part of it. About remote
adding more RHEL
monitoring.
compute nodes, maybe. That was the one I saw.
Who's our friend on the docs team? Can I offer some help in there?
Good question.
So
it should be on here.
So Waleed,
I saw it here.
I see you. Waleed, I see you in the chat. Don't worry. We see everybody in the chat. Trust me. So Waleed, yes, it is. There's no bespoke. This is the same thing for everyone. There's different works and frameworks and agreements and thresholds. Like if you buy a certain amount of OpenShift subs, you're going to get a certain amount of this and that and so forth, so on, kind of for free kind of deal. It's just part of the package, right? So every deal is different as far as sales go. We're not here to talk about the sales part. We're talking about the de facto subscription models and the, kind of where things are based off of. Just to give you an idea of where you're going.
Okay, and
I actually don't think it's on this.
Okay, well, you continue looking. I'll give some more questions out of the chat.
Yeah.
Can you explain in detail about below support types, which one needs subscription and which one not? Needless premium, standard, self-support, and evaluation. And kind of on the same train from YouTube, for the 60 days trial, do we get support from Red Hat?
So support is an interesting word at Red Hat.
Yeah.
Right. So when we say support at Red Hat, we're talking about the whole thing, right? Like the code, what's running, oftentimes there's a lot involved in quote support. If you go to developers.redhat.com and you download the trial, or not the trial, but you download the software and you're working in that 60-day, you're not going to get support for that, right? You'll get, I think, what is it, email support or forum support kind of deal?
There is. I can actually show that. So
yeah, go ahead.
If we want to put this on the back burner a little bit,
just tab over and show the developers first, because that's what we talked about first, and then we'll get into the corporate side, right? Like the enterprise side.
Show the different SLAs for support. Yeah.
Go ahead.
So
premium, standard, self-support, evaluation. Yeah.
So So premium. So just real quick, high level, premium standard are ones you need a subscription for. Self-support is at 60-day. So not sorry. Self-support is what you need to do after the 60-day, and evaluation is a 60-day. So
yeah.
But if you go to cloud.redhat.com, this is really your I guess window right into all your OpenShift installations, right? So if you go here and I go cloud.openshift.com, cloud.redhat.com/OpenShift, you will see here
that I have a lot of clusters.
I have a lot. This is all the clusters I have a ton.
This is everybody at Red Hat, right? Just because of or is this you?
This is
just
me.
you. This is just
me.
you.
This is just me. Yeah. So as you can see, I do a lot of testing.
Good Lord, Christian, dude. What have you been like? Okay, now we know why you don't have COVID.
Yeah, exactly. Yeah, because I just stay indoor and play with OpenShift. So this one, so this gives you kind of an overview of all your all the clusters that you have here, and as you can see here, this one is a 60-day trial, and I think it's expiring. It says expires in 7 days, right?
Yeah, okay.
And then here you have the I have the
tells you what the
60-day.
SLA is. Yeah.
That's what your SLA is, and you can edit description settings, right? So I can say 60 evaluation or self-support, meaning after the evaluation is done.
Right. Like once the evaluation is actually done, what do you lose by going to self-support?
The ability to call us.
So you do get some, but self-support 60-day, you don't get to call us, right?
You do, yeah. So you do in the 60-day, yeah. You get a really, really low.
Boom. Today I learned.
Today you learned, right? So here you have, you say self-support. And then what are you using this cluster for, right? Disaster recovery, production, dev test. This is just for analytics purposes, right? It'll eventually become something else later on, but just for you now. And then if you want L1 to L3 or only L3s, level 3, right? So it's like L3 is like, oh hey, I'm down.
Down hard.
No, I think it's the other way around. Wait. I believe L3 is that
L3 is like
is lower.
Question.
Yeah, like question.
Like Sev 0 is terrible. Everything's off. Right. Yeah.
Okay, and we have a question of with self-support, do they get cluster updates?
Yes.
For the evaluation period, I don't know if they. I think for self-support they do as well. For the
I think so. There's nothing in the operator to prevent it.
Yeah,
I don't think, right?
It's in the for now, I think it's we're always evaluating.
So, but question number 4 on this page is very valid, right? Like as mentioned in chat, what unit of measure do you want to use, cores or sockets, right? Like cores / vCPUs.
Views or
sockets,
right?
Yeah, so, let's.
Yeah. So if we break this down.
Is there like a master page behind that page of docs like that we could show folks, or you're going to show us? Oh, here we go.
Yeah. So first I need to let me go to my Twitch. Is there anything here? No, I don't. Let me log into my cluster. Actually, that would be good.
Wait, which cluster?
My cluster, my home cluster. So this is my home cluster. There's no cloud. Maybe make this a little bigger.
Thank you.
Is that too big?
No, that's way too big.
That's because we're geeks and we run our own stuff in the houses.
Yeah, exactly. I mean, we do. I mean, that's oops.
So I don't have a cluster in my house. I think I'm the only one. I think I'm the only one on the team that does not have.
I think it's because you use most of your stuff for.
Most of my stuff is for streaming.
Yeah, for streaming. Yeah, mostly. So I have.
Like, I would love to go get a piece of hardware to run a cluster in my house. Like, trust me, I would love that. But all my gear is used for streaming right now.
Name service. Oh wait, I need to. Hopefully this doesn't boot me off. I need to disconnect from the VPN. Okay. Always a problem with the VPN.
I did that the other day. It was fine.
Yeah. All right. So then here I have. So I can do OC get. I think it's cluster version. It says on 466. YAML. And I believe I am looking for.
Taylor Trick 51. How's it going?
Okay, so let's see if let's make this. Let's go off on a little tangent.
Here we go. Even your clear command didn't work.
Even my clear command didn't work. So it's items. Spec.
None of us here speak French. I don't.
Spec
Christian
or
does.
cluster ID.
Christian speaks
No,
French.
I do
Jafar
not.
speaks French and Christian.
Jafar speaks French.
Christian speaks Spanish.
Someone says "Cómo se va?"
That was me. 'Cause it's
In
one
French,
of the few
which
things I
means
know.
the only I can read French maybe
Yeah,
a little bit just because I know Spanish, but
Right.
Right.
if someone talks to me in French, it sounds like they're talking with marbles in their mouth. I have no idea what they're saying.
No. Yeah. I couldn't. No.
and it's someone speaking Italian, I can understand it if they speak it slow enough, even though I don't speak Italian.
I can get around in Europe because I speak just enough words of a few different languages.
Yeah.
No,
Just
I'm
enough
the
to
dumb
ask where the
American.
restroom is, I think is important.
Yeah, I stick out like a sore thumb, so I always play the dumb American.
So items spec, and then cluster ID is what I'm looking for. So let's do
No, we don't speak Italian. We have Jafar on our team who is
who
from
speaks French.
He speaks French and he's from Morocco, so I'm sure there's a few other languages in there.
Items spec and then cluster ID, or is it ID? Well, let's do one or the other. So this, how good is your JQ foo?
God. That was an error. Wait,
cluster.
did you? No, you.
Oh,
Something.
there's OJ Son
right here. Yeah.
There we go. So this is what we want, right? So what we want is your cluster ID, and actually let's do this. I'm just showing off at this point. There we go. If you worked with Kubernetes as long as I was there from the beginning. So like
yeah.
So some of the stuff, and this, because I used to see people like type this stuff out. I was like, man, I better start learning this.
Yeah, I thought I had been in the community a while until I got to this team, and then I was like,
yeah.
Nope.
So someone says I got this ID from the UI. See, but
yes, you can totally go into your console, your web UI, and get it very easily. But
it doesn't look as cool.
Off.
By the way,
yeah.
So it doesn't look as cool, right? Like, yeah, you can log into the web UI, but it you want some geek cred, right? So let's go back to clusters.
Also, he has so many clusters. So
True.
No, he's talking about in the OpenShift web UI.
No, I know, but I'm saying you would have to choose from.
From one of my many clusters.
Yeah.
Right? So here I have so this is my cluster, right? I just typed it in my search. My status is up, so it's good. I got
cool.
I'm on the 60-day trial.
So you just spun this up recently?
No, it's been recently.
Well, you spun it up within the past 60 days as well.
The 60 day, yeah, it's been 20 days, right?
Okay.
So it kind of gives you kind of cool usage and memory.
Yeah. Okay.
What you want to pay attention to here, though, is I think here it says my subscription obligation is I'm obligated to give 12 cores.
Ooh.
Like, so how does it calculate that? So remember I said one subscription is equal to 2 cores?
Yep.
We don't count masters.
We don't count the control plane at all?
At all. So the masters, whatever cores are in the masters.
So just like the cloud providers, we don't count the control plane.
We do not count the control plane. We give that to you for free. So that's your
but unlike the cloud providers, you can make your master schedulable, right?
Correct. Then we do count.
You could put workloads on your masters if you want.
But you're gonna pay.
Yeah. So we don't count the cores on the masters. So you just count the cores on the workers.
Right.
Now, we also have this concept of infrastructure nodes, right?
Yes.
What are infrastructure nodes? Infrastructure nodes are things. There's workloads in OpenShift that have to run in order for the cluster just to be up and running, right? So things that we install, like the router, right? The OpenShift router that's based on HA proxy, the ingress controller.
Mm-hmm.
That's a core component. So that would count as a infra workload. The registry is another one, right? Yeah. Things like that, right? Monitoring. So the things like Prometheus and Grafana.
Yeah.
and the log, the EFK stack. So the
F
log
stack,
aggregation. So all that stuff is
it's infrastructure, right? Like you need
infrastructure. Yeah. So if you label your node as an infra node and then move your workloads over to that node, we don't count those either. So it's based on a few things, right? Okay. So it's based on the
you have to type the node.
Yeah. So there's two things. So there's one is the node is properly labeled as an infra node, right? So if I go,
where would you do that? Yeah.
So if I do OC get pods, get nodes, right? I have 3 masters and 3 workers.
Yep, standard cluster,
right?
Yeah.
All right, and this is labeled as a worker, and this is labeled as a master, right? So if I do, if I can see if I can do this from memory, OC get nodes -L. Is it Kubernetes? You know what? I don't know.
Oh man, I had a whole sound effect geared up. In the back of my mind
there you go.
That's Amy's
node
sound
roll
effect.
is what it is. Right, so it's node-roll.kubernetes.
Okay.
I was gonna type kubernetes.node roll, but no, it's
right. That makes sense.
Kubernetes, IO /
the
worker equals nothing, right? And this will show me all the workers.
Just the workers,
right? Yeah. So if you do infra, right? I got nothing, right?
Nothing.
Because I don't have infra nodes because I'm a Red Hat employee. I don't have to worry about that. But
he's telling you to use the UI, by the way.
You can use the UI. Everyone loves the UI.
Christian is more comfortable in the command line.
I am very comfortable in the command line.
We can do the command line. If you ever
see me use the UI, I look really
You're just like lost.
I'm like funny. Really, I'm like, how do I?
Meanwhile, I'm like the UI is like my best friend.
Yeah.
Yeah. Okay, so like, it's I just want to run through chat real quick.
Oh, go ahead. Yeah.
Okay, this one's kind of related to Salah. I hope you can make a episode about the catalog operators. I wonder if you can have an application catalog mirrored through private internal registry and disconnected network environment. I'm working on that. So that'll be coming up soon. We were actually just talking about that.
Off camera, obviously, but we were talking about like during work hours, we were talking about
right. So that's in progress. Don't worry. Disconnected install, like we were talking on Tuesday, I think it was, on the stream, and there was like a mass like conversation happening about disconnected install. So that immediately got my brain going, and we've been talking about it. So that's coming. Next thing, let's see. So GCP pricing for blah blah blah. GKE.
What is the advantage of using a self-supported subscription of OpenShift versus using the OKD? Stability.
Stability, yeah.
Yeah, essentially stability, yeah.
So OKD is
will be a hidden features.
OKD, so OKD is the upstream of OpenShift, correct? Or did I do that right? Yes. So OKD is what we build OpenShift from. So much like Fedora is where we test all the fun stuff for future releases of Red Hat down the line. OKD is the same thing. However, OKD you will not get any support for from Red Hat ever. So unless you are converting them into OpenShift clusters, which is actually very easy to do now. My understanding is at least with the newer versions, the newer betas. So for the newer so like actually for a while there you were actually able to add Fedora CoreOS nodes to OpenShift OCP, not even OKD, OCP. So like they were like for likes, but so that's like the biggest thing, right? So it's like support, upgrades, things like that. Well, not upgrades, patches and things like that. So infra nodes. So I was just saying you don't count those cores. So so the infra nodes are running Prometheus and FStack and Alert Manager and all that fun stuff. What am I not going to be able to run on those nodes? Your workloads. Anything else, right? Yeah. So like any other workloads. So those will be unschedulable for like anybody,
Yeah.
My name's Joe, and I'm in this namespace kind of thing.
So in order to get like a good infra node, there's like a few things. You need to have the label, right? Obviously on the actual node. 2, you need to have the node selector for those workloads, and 3, any taints that you need to do in order to repel workloads away from them. This is actually a good time to show the documentation page. Setting up worker infra nodes is a day 2 task currently.
Yeah. And there's a reason for that, right? Like so we make the install of OpenShift very easy with our API, right? Like we want to make sure that there's an OpenShift standard that is installed. Going from there and then making infra nodes, I think is very important, because you want, as your cluster scales, you're going to want more capability to monitor it, as well as add more, just resiliency in general. So
the installer for OpenShift is MVP, right? Minimum viable product. So we're like, once you start like trying to design an installation in one command, and like just that whole if and or buts that come with like everyone's different workloads, it's impossible to create a general installer that has like
perfect everything.
Like, so like you want like full automation or full customization. Like you're either on one side or the other, right? Like you're gonna sacrifice something.
It's a
for the
spectrum,
other.
and it's like a big switch between the two.
I like Ben Briard, who's just one of our product managers. He's probably one of the product managers for Red Hat Core OS, actually. But he has a saying back when we were both in the field, so I'm going way back. But he always has a saying, like, which I really like, is you have to pay the tax somewhere. You have to decide where you want to pay the tax. Yeah. So this talk kind of outlines how to create infrastructure nodes, right? And then how to move those further down in the document. How to move those workloads.
Those are on existing masters, right? And you got to push them off.
Well, those are on existing workers. Yeah.
Workers.
Masters,
sorry. Yeah.
And okay, so quick question from the chat, because it's kind of related to this. How do you decide on the number of master, worker, and infra nodes? Now, you showed you had 3 masters, 3 workers. Is that for redundancy? Kind of like
that is for HA.
Galera cluster? Yeah.
So minimum, you need 3 masters. And that is because of etcd, right? So etcd
HA has to have at least 3.
In order to get full quorum, you need 3. And since etcd is running on the masters, vis-a-vis, you have to have 3 masters. Masters are actually pretty stateless. The API is just like a stateless application. It's just the fact that etcd is on it. Before anyone asks, no, you cannot run etcd outside the masters. So for the workers, you need at least...
There is an etcd operator, though, if you want to use etcd for something else.
For something else, yes. But not for like OpenShift.
Not for actual OpenShift infrastructure.
For the workers, you need at least 2, right? So, and that's for the router, right? So the router, you need to get full HA, you need 2 routers, right? So that's that's like where you start in order to get HA, right? Yeah, there's ways to get 1 master and like 12 workers, right? But like we won't support it anyway, so why do we even talk about it? So, but yeah, so that's the minimum: 3 masters and 2 workers. So
and infra.
There's no minimum. There's no requirement for infra. So that's, like I was saying, that's a day 2 task.
Right. Like if you're with bare worker nodes, if you have 2 or 3 of them, you don't need infra nodes, right? Like you're barely touching the surface of the resources there. So that's the idea behind that.
Yeah. So someone has actually from about the sizing. Actually, 250 pods per worker.
250 pod per worker.
I believe we increased that.
That's a old number. I don't want to say it's 500, but I think it's 500.
I believe it's 500 now, and I believe they haven't updated.
It's only in 4.4.
Yeah.
But yeah, for now, think 250, but in the future, you're going to be thinking 500. I think is what really matters. And that's just, we'll support.
And that's max, by the way.
Yeah, we'll
and then it's all dependent on your application
in theory, but it's going to be spreading out across multiple nodes there.
So number of pods, 500.
Yeah, so what Christian has here is our actual tested maxes, right? This is what we've tested in-house.
Yeah, and someone pointed out, which I'm saying it kind of depends on your workload, right?
Right,
So
like it's 100% dependent upon your workload.
Yeah, it's like I would say this is just
I can't tell you how your application is going to perform on OpenShift.
Right.
I didn't write your app.
If you're gonna take your 500 gig EAP application, stuff it into a container, I mean, well, first of all, you're doing it wrong, and second, you only be able to run that one pod, right, in that one worker, because you're not gonna hit that 500.
Let's clear some FUD up here. Salah, it is my understanding that OCP4X infra nodes and master nodes are merged together. That is not correct.
That is not correct. The workloads so masters are running
etcd,
OpenShift API, Kubernetes
OpenShift API, K8s API.
All the Kubernetes stuff, right? Like the scheduler, the controller
manager, all the Kubernetes bits that are necessary.
Scheduler, controller manager.
Everything. All that is there. On the worker side is where the infra nodes are originally when you spin up a cluster. Having detached or separate infra nodes, having independent infra nodes is what we're talking about right now.
So
I probably just completely took you off track. Sorry.
Yeah. No. I'm trying to pose a question to see if
if I have a massive Java portal that has 120 applets behind it, of course it's going to perform completely differently.
Yeah.
On GCP versus AWS, right? Like, so we can't tell you how your app is going to perform on any kind of thing because we didn't build your app.
Correct. Yeah.
So unless you have like great numbers, which will, if we're doing an engagement with you, we'll ask you, like what kind of performance are you doing? Unless you have great metrics around that already, it's hard to give you an idea of what you'll need.
Yeah. When I was in the field, anytime some customer would ask me, how do I size this? And I was like, good question. You tell me.
Yeah.
Because I don't know your workloads, right? Like, I don't know what you're going to put on. I don't know what metrics do you have. What, I can tell you what overhead you're going to need to run OpenShift, but beyond that, what is your app doing? What your app need?
I mean, your app could be just absolutely,
Are you doing greenfield, brownfield?
Right. Yeah. It could be out of memory just all the time, killing itself.
Are you running OpenShift virtualization?
Yeah,
right? Like it's
like are you using service mesh? Are you using are you running multiple registries, right? Like all your operational excellence matters too, right? Like having your pipelines in place, all that stuff runs, and it all counts, right?
So if I have here, Red Hat is telling me that I need 12 cores to satisfy this cluster. Okay. So if I have 3 masters and we're not counting masters don't count.
Control plane's free.
And I have no infra nodes, so we don't have to worry about that. So if I have 3 compute, how many cores do you think each compute has?
4. Right?
There we go.
No,
so
am I doing the math wrong? 3 compute, 3 times 4 is 12, right?
3 times 4 is 12, right? So
holy shit, I did public math.
There we go. But how does it determine, right? So there's a so sorry, people are going to say this is behind a paywall, and I say no, it's not, because creating an account is free. But other than that,
please create an account and read this article, right?
Yeah,
if you're concerned about this.
Yeah, if you're concerned about this, how do I determine if my x86 compatible Intel system is multi-processor, multi-core, or supports hyper-threading? So this is a lot of this is a lot of the stuff that like I was like knee deep into this doc for like a week. So the main potatoes is really here, right? Is really in these bullet points, right? So I think they wrote it eloquently here. So I'm just gonna read off. It says the physical ID value is the number assigned to each processor socket, right? So when you're running the command, let's say what is it, cat proc CPU, right? CPU info. The physical ID value is the number of assigned to each processor socket. The number of unique physical ID values on the system tells you the number of CPU socket that are in there, right?
I can put this in better English.
Yeah.
I mean, unless you want to.
Well, right? let's say let's SSH into one of the
go ahead. Let's cat it out, right? Because
so this is
everything starts at 0. Right, like that's the important note here. Like we don't start at 1 in Linux world; we start at 0.
Some people are getting ahead of me. Yeah, but
yeah, LSCPI or LSCPU, whatever. Yeah.
You guys stole my thunder because I was gonna cat proc CPU info, and I was
You're not gonna steal these folks' thunder anymore, man. Like you can't jump ahead of chat now. Yeah, we're in too many places. Yeah,
man. These people are like LSCPU.
No, as we add Periscope and LinkedIn, you're not like we had. What was it? I can't remember which day it was. I think it must have been Thursday or Wednesday. We had like self-supporting like stream going, right? Like the chat was handling itself.
Yeah,
I was just monitoring it. It was just like, yep, that's the right answer. Might not have been how I've put it.
How I've done it, but that's the right answer.
That's the right answer. You know.
So the answer to you, Mr. Farley, is no. You would never have more than 3 masters, and currently we don't support more than 3 masters.
And why is that? Because etcd is kind of.
So unfortunately, one of the consultants, who I really like, he did an engagement with a customer where he found out the hard way why you would never want to scale this.
Okay.
And he has a great explanations about etcd and the raft algorithm and the
it is an etcd dependency.
It's etcd. So what ends up happening is that the high level is that what you gain in fault tolerance isn't enough to what you're losing in performance.
Right.
Anytime you scale etcd, you're going to lose performance.
Yes, because it has to write to more nodes.
Yeah, exactly. It has to write to more nodes and it has to do that whole, it's
I'm
the
gonna work on
algorithm.
Right. I'm going to work on an etcd show, folks. So don't.
Yeah, that'd be actually, Nate, if you're watching this later on, because he's on PTO, so that's why I hope he's not watching. Hope he's not working either.
But he might be enjoying himself,
Oh, he might be. Yeah, he might have a cold beverage. Yeah. So, anyways, I would love to have him on because he has like the best explanation. But anyways, you gain fault tolerance, right? But you lose so much performance.
Yeah,
that it's not worth it, right? The cost is opportunity loss.
Right.
Cost,
sunk cost fallacy.
Yeah. Or I forget what it is. If there's any.
No, not that. It's the other one. Yeah, you're right.
Yeah, loss. Yeah, opportunity lost. Cost or whatever, right? Like you're
JP Dade is at the beach. Okay, cool.
He's at the beach. Nice.
Awesome. Very nice.
So, anyways, you lose performance.
Yeah. And it's not like linear either. It's algorithmic.
Algorithmic.
Like exponential performance.
Yeah, exactly. Yeah. So he has a hope for the etcd. Hopefully, we can get him on. He knows.
Yeah.
He knows way more about etcd than I do, and he says he can get someone else on that knows way more than he does. So, anyways,
I got connections. Don't worry.
Oh, that's right, Mr. Cloud Native ambassador here. That's right.
Don't make me put the cape on.
Yeah. Here, OpenShift gives you a warning. Don't SSH.
Do it.
So, actually, this may be disabled in the future. So, I just want to show everyone a quick trick. So, like, are you gonna disable SSH into my nodes? I can't SSH to my nodes. If you want to do OC debug node, and then the name of your node, this will actually
it's going to touch your node. It's going to reach out and
it basically launches a container that's a privileged container on the right. If I do ch root to /host, and then I do bash, I'm on the node, right? So
holy smokes. Okay. Today I learned twice.
There you go. Oh yeah, and someone says
Duffy did do an awesome TGIK.
Duffy did an amazing TGIK one on etcd. So if you guys want to check that out, he's amazing on that.
Yeah, thank you, Waleed.
So I'm on there. So today you learned, right? So
so
when they take away SSH, you can still debug your nodes. So let's cat.
And why would we ever take away SSH from people? Because those nodes,
they're managed by the platform.
They're managed by the platform. The platform is going to be self-managing. That's the idea, is that you don't manage the platform. The operators do.
So I have an awesome egrep here that I can copy and paste.
Please do.
So I do want points for this, even though I'm copying and pasting it, because I came up with it. And there's actually a set here that I'm gonna do later. I didn't copy and paste the Stack Overflow.
I was about to say this egrep is not very impressive.
Yeah. So I have some said. So here, this will show you this will basically print a new line.
Yeah.
Right.
Oh, okay. Okay,
So here,
that's better. Thank you.
Yeah. So here you see the physical ID.
Yeah.
I have.
It's still socket 0.
Socket 0.
Right.
This one says 2.
Socket 2.
Wait, am I on the right?
Am I reading this
cluster?
wrong? Core ID is 0.
I did not want to show this cluster. Still same idea, folks. All right. Let's see if I can do this by memory. Get.
Oh my god.
Although it might be useful to show it, but
Oh jeez. I didn't want to use this cluster.
Is that resource type? Oh, cluster.
Isn't it cluster dot version? Yeah, Augur's face. Yeah, no space version.
Yeah. Okay. Oops. I need to move some stuff here. Okay. But same idea, right?
Okay.
Actually, you can see the difference.
So what was the other cluster?
That was my VMware cluster, which there's nothing wrong with that, but
it's just
I want to emulate. I want to emulate a bare metal.
Different. Yeah.
I want to take a look at a bare metal one, right? So this one says
metal
8.
First.
Yeah, so 8 cores. So now I want you to do the math here. 8 cores, but 3 nodes. How does that work out? Can you do that math?
Wait. 8 cores, 3 nodes.
So I need 8 cores for the subscription, but I only have 3 nodes. So what's that math work out to?
It doesn't work. It doesn't. That's not divisible.
2.
What did you
3,
do?
3.
This is a virtual machine, right?
Yeah, this is the reason why I wanted to use this cluster, right?
Okay.
So
Yeah, 2.33
So
what did you do? Some kind of rate limiting?
or 2.66.
Or was it the other one?
God, he doesn't even know what client.
Is this because I have 2 workers? Is it reporting 3 workers? So this is weird because this one has a Windows node on it, but let's roll with it, right? So I do have a Windows node running.
Okay. Jesus. You have so many clusters, it makes me laugh.
I have so many clusters. Yeah, exactly. It's insane how I'm like, this one has a Windows node on it, so just pretend that Windows node is not there.
No
All right, so I have a physical ID of 0, physical ID of 2, physical ID of 4, physical ID of. Is this right? No, actually, I think.
What?
I think I messed up here. Yeah, there we go.
Am I? Okay. I'm sorry. I'm trying to do 2 things at once.
There we go. So the LSC CPU.
There you go. Thank you.
So I have 4 sockets. Right. So I have 4 sockets. I have 1 core per socket.
Okay.
And each core has 1 thread.
Okay.
Right. So essentially each worker has 4 cores in it.
Each worker has 4 cores, so we don't charge for the control plane, and you only have 2 workers, and we give 2 away for free.
Well, we don't give 2 away for free.
It's not.
We don't charge for the masters.
We don't. Windows.
Masters.
Yeah,
right. Sorry.
Yeah. This is not counting the Windows. Yeah.
Not counting the Windows one. Yeah. Sorry.
So this tells me that the Windows 8 cores here. The Windows Windows node is free for whatever reason, but whatever. So no multi-threading. So this is exactly what the reason why I wanted to use this cluster is for that exact. This guy gets it. Is that I'm not using multi-threading, right? So I essentially have to count each core, and I have 4 sockets per core, right?
Right.
But
you're doing vCPU pricing. Right?
No.
Okay.
So
you're doing core pricing. Okay.
So I have core pricing, right? Because I have 4 sockets.
Okay.
And I have 1, right? So that's 4.
4.
Right? And I have 2 workers, so 4 plus 4, right?
8. Makes sense.
8, right? So it makes sense, right?
Yeah.
So
now I get it. No, stop it. It's
can
actually
can you do math
it's
there? Yes,
yeah.
Okay.
Oh my god. I thought you had to use BC for math. I didn't
Yeah,
realize you could use Echo for math. Oh my god!
Well, it's Bash.
Today I learned 3.
Today you learned you can use Bash for math. Does Core OS have BC? Yes, it does. Okay.
Yeah, it should. Yeah, it's got the standard like Red Hat package set. So yeah, BC's in there.
Yeah. So this compute had this it has 2 because it's not counting the Windows node. So just ignore the Windows node. Ignore the Windows node. But I do have a Windows node, by the way. If you want to see.
Yes, it's very cool, but yes.
So anyway, and so let's go back. Oh, I didn't want to do that.
But Willie might be the smartest person on the streams.
Right,
lately.
yeah.
Yeah.
He is. We should get him like a T-shirt or something.
Well, the problem is he's in like Saudi Arabia, so the shipping's gonna be a pain. But yeah,
if you can pay for the shipping, we'll send you a free
No,
T-shirt.
I can get it there. I just need to know where.
Yeah.
So Willie, send me an email. C-short.
Oh, we got a subscriber.
Yeah. So
Nice.
we did. Nice.
Yeah,
Thank you.
nice. Thank you for subscribing.
Yeah.
Yes, please follow us on Twitter. Not on Twitter, on Twitch.
On Twitch, yes.
Don't tell them to follow us on Twitter. They already do.
Yeah, so I get so here I have, so if we go back to this cluster, the one
we're not supposed to look at. Yeah.
Well, no, the one I wanted to show you second, but I showed you first by where is that?
Do you charge licensing for workers or for masters? We don't charge for masters. Red Hat support told me that they charge for workers only. That is correct.
That is correct.
And we don't charge for infra?
We don't charge for infra. But that's up to you to set up, right?
Right. You are setting that up your own. Yeah.
Yeah. So that's incentive for you to set up infra nodes, because as soon as you get that workload off, we don't charge you for those.
I just saw that JP Dade said, don't put etcd on NFS. That is for sure.
Yeah, that is for sure. Yeah.
I just saw that. Sorry.
So here, this one says.
How's this one doing?
This one is, I need to edit subscription settings. I want self-support.
You did
is
cores.
on self-support. All right, cool.
Yeah,
so this one I have 12 cores. And this one I actually do have 3 compute.
Right.
Okay. So this should work out the same way, right? Oops. Let's do the debug.
Isn't it this the first one we were looking at?
Yeah.
One.
Okay.
I wanted to show you second, but I showed you first by accident.
Now he's just going to do the fancy math thing that I just learned.
Yeah. So here.
So no charge for Windows nodes in worker role. I would assume that would be correct.
That is, worker nodes. No. So I want to.
So wait, yeah. Can we have Windows worker? Well, of course we can have Windows worker.
Well, we just had one.
Yeah.
We had a Windows worker node, and Windows workers are dev preview, meaning that they're free. Way out. Because they're free because we're currently developing on it.
Right. Yeah. Like so dev
there's no way that Microsoft's going to let you have a free node. So
right. Like so dev preview comes before tech preview, which comes before regular production work for folks and not in the Red Hat wheelhouse that, Yeah.
So if you're testing on worker nodes and want to provide a feedback, it's 100% free. You just have to pay whatever Windows licensing.
Yeah, whatever the licensing for Windows is.
Or if you want to use a 60-day trial, then fine, do that.
Yeah, like we actually do for a lot of our demos. We have a trial version that we have floating around right now that we use a Windows 2019 node. You can use your own. Oh yeah, you can use the demo versions of Windows in your worker nodes if you want.
Can OpenShift orchestrate Windows containers?
Yes.
Yeah. That's not been a problem for a while, right?
Yeah. No. Yeah. You can do that.
Yeah. It's not the Windows containers. It's the Windows like actual worker.
I can show you that.
The problem.
We're
talking about subs.
Yeah. That's like a big tangent.
My job is supposed to keep us on track here. So yeah.
I can.
Windows contaurs should
I can come back and do Windows containers.
So I have heard that about 100 times, and I've been in the BU for about a year. So yeah. Windows auth is totally possible. You can totally get AD
all that good stuff
with
AD working with OpenShift.
But subs.
We're awesome.
On subs.
Subs.
It kicked me out.
JP Dade, come back for Windows nodes later. Christian will definitely have something on that.
I will have something on Windows nodes, yes.
And we'll do the Windows container and the Windows worker, right? Like that's the promise.
Yes, right? Windows. Yeah. Yep. So here I have again 4 sockets, but only 1 core and 1 thread per. So this math is also easy, right? So I have 3 workers, right? So let's do the Chris Short math. 4 plus 4.
I love that this is
4
short math now. Can you please
12 cores, right? So you can see here, I have 3 times 4 is 12. So this is essentially, you're basically, it's probably like the easiest, but it does get kind of weird when you're hyper-threading and all that. But the easiest thing is basically you count how much cores your workers are.
Yeah. It's pretty simple math from that.
And then since we don't charge for masters or anything like that, you're just paying for your workload, essentially, right? So someone's asking GA for Windows nodes. Okay.
Yeah.
We're targeting 4.7.
Target.
Subject. Big banner, subject to change. It's depending on a lot of things. That's our target. So
targets are things. They are not firm dates.
Yeah. So
it's a challenge. I'll just leave it at that.
So I wish I had. Do you have?
Do you need a node?
I wonder. Yeah. Let's take a look at like a hyper-threaded one. I don't have a hyper-threaded one because.
So this should be hyper-threaded, right? In RHPDS, yeah.
I guess we'll see.
Yeah.
It shouldn't be actually, right? Because it's AWS.
Right. It should be whatever is going on. Where the hell is Christian in my Slack? I'm gonna send it to you on Slack. Is that cool?
Okay. Yeah.
Okay. There you go. All the details for you.
Here's some important information. Oh, you just literally copied and pasted.
Literally copy pasted.
So let's do. I don't want.
So JP date, that is 3 versions away. Yes. Yeah, it's hard. We've had.
Yeah, you're looking end of year, early next year. Sort
of but I mean, it's not entirely the technology fault either, right? Like, COVID-19 has had a detrimental effect on productivity, I think, nationwide. So, working with our partners at Microsoft, working with, internally, right? Like, there's been just slowdowns. We're not afraid to say that because that's kind of the state of the world right now. I love how I spun up this cluster this morning, knowing we were going to use it.
There we go. So here.
It's only got 2 workers. Okay.
2 workers, right? Let's
okay, so that's the new.
So can we SSH into it? No, because it's
yeah, it's internal. Yeah, so
that's why you need the OCD big node, by the way.
Right.
It's
yeah.
Because you're not able to SSH into your AWS instances. Mm-hmm. So.
Yeah, so everybody don't ever try to run etcd with just 2 nodes. Ever.
Yeah, don't do that.
Ever.
Not in production, at least.
Well, yeah, I mean, if you're testing stuff, sure, but yeah, don't do it in prod.
Yeah. So
JP Date says, yeah, I'm working more now than I did when I had to commute to work 3 hours every day. Well, I work from home and I work more now than I have.
So I think all 3 of us are.
There's more email, there's more chatter, there's more everything. Yep.
So like I've always worked from home, but like I'm way busier now because now there's new people working from home and people just take the slots out of your calendar. So
yep. And you have to hang out with me, which I do love. Right. Like, I'm not complaining about that, but I am taking time. So yeah.
That's right. So let's see here. This thing has 1 socket. 8 cores per socket.
And
2 threads.
2 threads per core.
2 threads per core. So this is a 16, right?
Yeah.
So this is 16. So let's because
8 threads per core. Yeah. 8 times 2 is 16. Okay, the sockets don't matter. Yeah, exactly. Okay, the sockets are still.
So this is a 16, but like, are we? How does this? Yeah. So like, how do you make sure, right? I don't have access to your cloud.redhat.com.
Oh, so yeah, you need that, don't you? Well, you don't need it, but you need a file, don't you?
Well, I mean, you can look it up.
I mean, I can share my screen too, right?
Yeah, I'll give you your cluster.
Well, this is RHPDS. So would it be in cloud?
Oh, yeah. Who would have the?
Who would have the? That would be those guys.
That would be those guys.
That would be Noe, not those guys. That'd be Noe and Patrick and Alyssa and those folks. Shout out to them because we love them because they keep us straightened and so forth.
Yeah, so let's
Speaking of which, actually, we're doing just for Red Hat plug real quick. July 15th, there will be redos of some of the Summit workshops. So I will be doing with my team of wonderful engineers the Ansible operators workshop again, and we're increasing the size to 125 people. So stunting on everybody else that are sitting at like 50 people in their labs. So yeah, join us July 15th. Look for more details at I think summit.redhat.com.
So this is a good sentence here in that doc I put in the chat.
Mm-hmm.
If the siblings and CPU cores values match, the processors do not support hyperthreading. So if the siblings.
So where were did we see the siblings?
So if the siblings and CPU cores values match.
Well, obviously, because hyperthreading is just times 2,
same,
right?
Yeah. So hyperthread is so this is actually
enabled.
Yeah. So siblings, so they don't match.
Okay.
Which means they are using hyperthreading.
They are using hyperthreading, which means that they're paying for 16.
They're paying for 16, correct? Yeah.
Right. Okay.
Not 8. So in this case, so this is the reason why I wanted to show like a hyperthreaded system versus non-hyperthreaded.
Yeah. No.
So if you don't have hyperthreading, so if this wasn't hyperthreading, so if I go back to LS CPU, where's my fancy egrep? My fancy egrep.
I love egrep.
Good old
like
egrep
program.
So if this wasn't, exactly.
Yeah.
If this wasn't hyperthreading, you'd be paying for 8 cores.
8. But because
it is hyperthreading, you're paying for 16.
16, right? Because you are using 16 cores, right? Like it's not like we don't. Intel does not distinguish hyper-threaded cores from regular cores, other than the fact that it says hyper-thread, right? Like they treat it as a 8-core thing for like physical core thing.
Yeah.
Right. So yeah, it's just if you can use it for compute, that's what we're going to charge you for.
Correct.
Done.
Correct.
Game over. Oh, dog's back. Went to the groomer today.
There we go. Yeah.
Hey, buddy, come here.
So
rolling around in her bed.
So there's a question for you, Chris.
Oh, snap.
Says, what is a thread?
What is a thread? Okay. Ooh. I don't know, to be honest with you. But no, I do know. So a thread. A thread is, let me do this right. So we have socket core, CPU thread, right? Is that how it works? A thread is a
socket core thread, right?
Yes. Socket core thread. Thread is not a process. It is, right? Like, no, we need to actually like give a good answer.
Single execution in a CPU. Probably the best summary I think I've ever read.
That's it. So like I wanted to give a scientific summary, but yeah, that's probably right. Like a process has a lot of
threads.
Potentially, you can have single thread processes, but if you do like a top or a PS kind of command, like a PS AUX FW or whatever, you will see children process. Actually, get out of top real quick. I'll tell you the command to type in, and it'll be pretty and everybody. PS space AUX FWW.
Oh, aux F
WW.
It shows you the tree, right?
Yeah, it gives you the whole tree. So like, see how user lib exec AT SPI bus launcher, it has a child process. That is a thread. That child process is a thread. And then it launches another process. So a process can have a lot of threads. Yeah. So that's what a process is like you executed something, right? Like think of a pod as a process. Now it could have multiple child threads or processes. But yeah, there is a limit of threads on an operating system. It used to be that for Red Hat documentation, we told you to change that like every time because we're set so low.
Is that like is that the FS? What's it called?
No, it's the P something cuddle. PS cuddle? No, not PS cuddle.
sysctl, right?
Sysctl. Yeah. So when you do a sysctl
parameters,
good times.
Yeah, no, it's right there. Nope. Oh. Shit. It is like 65536 though. Like that's the number you're looking for.
The max
map count. No. But it's in that 65,000 range because I remember.
Yeah, it's a computer number.
Yeah,
obviously.
Well, but yeah, it's 64K essentially, right? Or plus whatever. Yeah. So the weird. I'm interested why you can't find it there. The idea is that the magic number is 65536.
36,
yeah.
Whether it's MKG, whatever it is.
Right. So the process will spawn multiple threads. Now, it used to be back in the day, Perl, for example, a super popular language, still very popular today from what I've been reading. It could not have multiprocessing until a certain version. And then that's when like the world blew up, because you could have multi-threaded, multi-process Perl processes, or any process, for that matter, and which point you had a lot more flexibility in your ability to program, right? It opened the door for a lot of cheaper compute, which opened the door for a lot of things like DNA sequencing and, any number of things that got, benefit from that. So, yeah, that's kind of just my spiel on that whole thing. So, yeah, we've jumped the number up here. Just insane number. Way higher.
It looks like I have 51.
500,000 threads.
Looks like I have 51,000 on this.
Yeah.
One. Whatever
threads. Yeah.
Yeah, so whatever that is.
512? Yeah. No, that's not
512, I guess, yeah.
That's like just under 512K. So yeah. There's what is.
But luckily we don't count those in OpenShift. We don't count the threads.
No, we sure don't count threads.
We're just like, let's keep it simple. Let's do cores.
But you know what? Threads might be part of that 95th percentile.
Correct, yeah.
If you could do threads as 95th percentile of threads, that might be a good pricing model.
Yeah.
That would be interesting.
Yeah, exactly. Huh. I say we submit it. I say we get the powers that be and say, you know what? The 95th percentile, I think, has worked for networks for years.
Yeah, it's done very good. So how about 95th percentile of OpenShift?
When you can consume, when you have this big pot that you can consume of.
Oh, JP Dead says cat proc sys kernel threads dash max.
Yeah, let's
we can chat real quick. Let's see what happens. What decides the thread limit? I mean, essentially, the OS administrator ulimit is involved, and all these other things are involved. What decides the thread limit? The CPU will tell you at some point what its thread limit is, but it is totally programmable at the OS level. So you would need root, but that's it.
Yeah.
But if you wanted to monitor by threads, you'd have to have something running on the machines to report it back to charge.
Yeah, you'd have to have an agent. Yeah. So, but we do have Prometheus running.
We do have Prometheus running.
And we've got Prometheus. We've got what's not Alert Manager. I always forget the third thing. There's Prometheus. There's node exporters.
But does that report back to Red Hat?
No, no, unless you let it.
Right. So that would be the hard part.
Yeah, exactly. How would you measure that? Anonymously, no less. So there is a thread. There should be always running in the kernel an active thread count. You use procfs, right? Like just on procfs. Cat,
it is,
like proc something. So yeah,
procstar.
A thread. So a thread is not a process. A thread is a process. A process can have multiple threads. Right. If that makes sense.
Yeah, this is already gone beyond what I know. So I'm
like we've gone way down the rabbit.
Yeah, way that rabbit hole. Yeah, because we don't go that far down for subscriptions.
Yeah, so like it's an instance of a process is not always accurate, right? Because a process can have child threads.
Yeah.
So it would be an amalgamation of all. It would be the total number of that entire process.
That's cool. Yeah, let's see.
Yeah,
see what Google says.
The subscription model, we're so far off that.
Yeah, I like that answer.
A process can have multiple threads. Exactly. So yeah, like most processes and in OpenShift, nowadays,
we don't count those.
Yeah, and most processes nowadays do have multiple threads.
Yeah.
Rabbit hole is the funnest part of computers. That isn't totally true.
That's
so my Java program can have multiple threads. Your Java program most definitely has multiple threads.
Definitely.
It spins up a JVM.
Unless it was written
spins up another thing. Right. Exactly. Right. Yeah. So like JVM spinning that up right there. Right. Like you got to spin that up. that's process. And then multiple processes or threads get spun off that JVM. So yeah, your Java app will most definitely have threads. And it has a thread limit that you could then program with those XX, settings and so forth, so on. So yeah, if you're not tuning your Java app, it could totally have not enough threads potentially. So I think a lot of the JDKs back in the day had really low limits on thread counts. So you had to tune it no matter what.
No matter what, you had to tune it. Yeah, I remember those.
We have a Java app that leashes its thread limit. Yeah, see, there you go.
Someone here mentioned the subscription, so I'm kind of setting.
Yes, licensing based on number of cores sounds expensive if you wish to have a big cluster.
Yes.
So we don't have a license; we have a subscription, but the same sentence still applies. Yes, so that's true.
Right.
If you have a big cluster,
a license implies that we have done proprietary something, right?
Yeah. There's no licensing; it's just subscription.
It's subscription, right? We are a subscription model process. The process gives birth to a thread or threads. Correct. JP Dade, thank you.
There we go. We went way down the rabbit hole with this one. I like it. And, let's talk about Silicon now. Let's just get.
You want to talk about Silicon?
Yeah.
I mean, Jess Freds, where are you? You've been diving into that stuff for so long. I should get her on to talk about core boot and all the stuff she's been doing over at Oxide. Yeah, that'd be cool. Because so an actual piece of silicon is very, very hard to make, and there's a high failure rate in some processes versus others, right? It depends on the manufacturing process. But so I worked at Cree, and I won't give away any proprietary information. So if you're from Raleigh in that area, you know what Cree is. But they make light bulbs, and they made more stuff than that. They had so many throwaway wafers because they grew the crystals in-house, and they had to then slice the crystals in-house. And if a slice happened just so imperfectly, it would just be a throwaway. So you would have this perfect little silicon disk that looked like this fully functioning, just stack of LEDs. And no, it's just a dead brick.
Wow.
Because only half of it would light up, or is the wrong color, or something, just slightly went off in the baking process for these things. And it can totally do that. Question in chat: can a Docker have a thread? Can a container have a thread limit? Absolutely. Anything can have a thread limit, essentially. It depends how you want to do it. Yeah.
It's actually pivotal that you actually do in Kubernetes.
Yes.
It's actually pivotal because the scheduling is based on your there's this concept of limit ranges, right? Mm-hmm. So you set the what your container can consume, what can it burst to, and the scheduler uses that to schedule containers onto the platform. And if you don't set those properly, or if you don't set them at all, if you get a spike and another container comes in and tries to schedule itself onto a node, and you're on that node, but you don't have your limit ranges set, Kubernetes will kill your container and saying, what, I don't know what you need, so I have to kill you. I have to stop your container because this other container tells me what it needs, and I know what it needs, and I know where to put it. I don't know what you need. I need to kill you because, so it's actually pivotal that you get those right. Mm-hmm. The constraints that you put on your containers and what they need for scheduling, or else they, and don't let your developers do it, because they'll say, I need 300 gigs of RAM. I'm like, no, you
have to have a capacity planning kind of function, not necessarily in the old school kind of way of we need to have 20% of, capacity in our data center kind of thing. But you have to have some kind of resource limitations. I tell people, if you're not putting resource limitations in your freaking KTML, I am going to murder you, right? That is a must. You must know how your application performs. If you have memory leaks, I don't care, right? Like you have to fix that, right? Like this is part of that moving towards pets.
Someone says
cattle, not pets.
Someone says limits are a great way to deal with memory leaks in apps. I guess that's absolutely true because it'll kill the app. You know what? Fine.
Start over, right? No, but a lot of people deal with Java that way. A lot of people dealt with Java apps that way because they could figure out what was causing the memory leak. So they would have a cron job that would just say, boom, start a new one, kill the old one. I have seen it in the field.
Wow, that's bad times.
Multiple times.
I've done that on non-containers.
Yeah. Right, like if you've written some, like pet project and it's kind of leaky code, you might want to do that.
Yeah, you have a cron that goes. No, I've seen that. You have a cron that goes down and goes. Restart everything for you. Restart Apache.
Restart whatever. Yeah.
The
people
JVM,
do it.
Whatever it is.
Yeah. I've seen it so many times.
So actually, we should probably put that on the docket as having a whole thing about
how to properly
ranges. Limit ranges.
Yeah. Let me.
That actually would be a pretty good one.
That's 3 sticky notes for you.
That's 3 sticky notes. Yeah.
Limit range show. You're absolutely right.
So because that's actually a good conversation to have because.
My client
a lot of people don't know how to use that. I've noticed when I was in the field, at least a lot of people didn't know how to leverage limit ranges.
Well, because you've been so unconstrained for so long, right? Like you were bumping up against VM limits. So my client is asking me to learn OpenShift Kubernetes. Good. I'm glad you're here.
Good.
Head to learn.openshift.com.
Yep. I was just about to type that in.
Step 1, learn.openshift.com. And then like step 1.5 is go to cloud.redhat.com. Get yourself some get yourself some Kubernetes, something, either code ready containers or something online to tinker with. But learn.openshift.com is a complete Katacoda environment to learn all the bits and pieces of Kubernetes and OpenShift and what the differences are.
Yeah. Also, another thing that Langdon will probably like me to say is that some of our classes that you usually would have to pay for are now free.
Yeah. So if let me just type it into the chat. red.ht/do101.
There we go. Do101.
Is do101 or do101 free? I could be wrong. They might have.
No, it's 101.
Yeah, do101.
Okay. Perfect. Yeah. That resolved. So there you go. So we have like free courses right now. So take advantage of that. Is OpenShift managed Kubernetes? No, but we can provide you a managed service. We do have managed Kubernetes if you need it. Or managed OpenShift if you need it. So give us a call. From the sizing PDF, we have a PDF. Okay.
Yeah. So there's it's some guidance and for me. So this is kind of...
If you run OpenShift infrastructure on your own, you're looking at $16K for a minimal configuration. Is that right?
$16K. That sounds about right. I mean, it depends
what year, right? Like,
that sounds like hardware, switches, and everything else.
I mean,
and also, what's minimal?
Yeah, right.
Like minimal for me would be different. Like company A would be minimal, different for company B.
Okay, what exactly is OpenShift Kubernetes? Who wants to take that? Who wants to take that?
We need like a whole show for that.
Do we really? I mean, we are over time. I am sorry, it's a Friday too. But what is OpenShift? OpenShift Kubernetes. OpenShift Kubernetes. We don't fork it. It's not a fork. We take Kubernetes, we bolt on some pieces, we add some some incredibly valuable SRE and Day2 type operational bits that you'll definitely have to have, because Kubernetes is never enough, right? You have to add logging, you have to add monitoring.
Yeah.
Go for it, Christian, let it rip.
Yeah, so if you've actually Kelsey Hightower probably said like the best like one line. He has like the best one-liners, I think, out of all. And I've followed Kelsey since he was at CoreOS, like since like the beginning, right? So he was he said that Kubernetes isn't the platform. Kubernetes is a platform to build other platforms, right?
Right.
So if people are saying I'm running bare Kubernetes, in production? No, you're not.
No, you're not.
No, you're not, because like you need an ingress. That's not built into Kubernetes, right? You need monitoring, right? That's not built in, so you have to add that. You need log aggregation. You need to add that. You need
Ingress
security.
is built in now, by the way. It is GA.
The object is
the chances of you actually running the latest version, if you're running vanilla Kubernetes, is also lower.
Well, and also you need security, right? So like if you're gonna do
the
like
operational
PSP
management of all that.
So if you know you're bolting on all these things, so like you're not. I mean, no one is really. But what OpenShift is a curated list of what we feel a platform should look like, right?
Vanilla Kubernetes is never enough. I'll just say that right now. Vanilla Kubernetes is never enough. It might be enough for like your home lab. It might be enough for your little Tinker project, or maybe enough for an IoT edge device that's connected to multiple other devices as part of a larger cluster. But Kubernetes by itself, like just the kubelet and the API and APIs, not enough. Never. You'll have to have monitoring. You'll have to have logging. You'll have to have event alerting. You'll have to have a bunch of stuff bolted on to Kubernetes. This is that build versus buy scenario, right?
Yeah.
Do you want to spend time? Are you a platform building company? Or are you a XYZ building company, right? Like, what do you want to spend your time doing? Do you want to innovate, or do you want to build Kubernetes clusters all day? Like what are you doing? You know, how do you want to operationalize yourself?
Like I always think of it as like a car, right? So like you have the drivetrain, right? The engine and the transmission. That's Kubernetes. Like, do you want to build your car off of that, or do you want to go and buy a Toyota like off the lot? Like
I just leased a Ford Escape, so
I
am definitely not making my own car, right? Like, so like, and you know, trust me, like I come from the community, right? Like I am known for my work in the community. OpenShift, in my opinion, is the best way to get started with full stack Kubernetes. So what exactly is OpenShift? OpenShift is Kubernetes with an Elasticsearch and FluentD and Kibana stack on it. It has all the things that you would Prometheus and Alert Manager, node exporters. It is built with operators so it can update and maintain itself. And it is also, it takes advantage of numerous security updates and performance tuning. So OpenShift is a managed offering. No, you can buy it. Yeah. We do have a managed offering.
We do have a managed offering. We do have what we call OSD, is OpenShift Dedicated.
OpenShift Dedicated, where, okay, I'm going to get this wrong. There's OpenShift Dedicated, and there's OpenShift where they run it in your cloud for you. Is that dedicated? That's something else, right?
That is also dedicated. Yeah.
That's dedicated. Okay.
There's two modes, but yeah.
Right. Okay, good. Thank you. So yeah, we can definitely like run it for you someplace. AWS, I think we run in GCP, and definitely Azure. We have we have an actual product. ARO is what we call it, but it's I forget what the ARO stands for.
Azure Red
Hat OpenShift. There you go.
That is supported by Azure for Microsoft, so you can
like
ARO,
Microsoft handles that for you.
Yeah, OpenShift Dedicated, you still call us, right? Because you have an SRE team, dedicated SRE team, whatever.
You got a TAM,
you got ARO, you call Microsoft. They support the whole thing for you, the Azure,
So if you have dedicated, you're calling Red Hat. If you're calling, try calling AWS the problem with your EKS cluster. Good luck. But sorry, I shouldn't have said that. The OpenShift Dedicated is for AWS and GCP for now. We're looking at getting it in more platforms. We just had a briefing with them.
Actually, no, it's Dedicated now is available on all three major clouds.
All three of the major ones, but I was talking about we're talking about other clouds as well now, right? Like we're just those three is not enough. What I love about OCP is how it integrates smoothly with the CI/CD pipeline. Yeah, like it has pipelines built into it that you can integrate very easily too. So yeah, I'm going to stop the OpenShift Love Fest though.
Yeah.
If you have more questions, hit us up on Twitter at OpenShift. If you have a need to get help, Always go to access.redhat.com. There's always resources there for you to learn. Go to try.openshift.com, learn.openshift.com, demo.openshift.com. We've got so much stuff to help you out there. Yeah.
We got so much OpenShift.com subdomains.
We've got so if you want like more of like a higher level, like everything in a box kind of thing, we probably should build like a landing page for the landing pages, right?
Landing page for landing pages. Yeah.
Well, a meta landing page. Yeah.
We'll call it a federated landing
Actually,
page,
you know what? I have one. If you go to OpenShift.tv, it takes you to a crappy looking GitHub.io page, but if you scroll all the way down, our CTAs that we roll through on the banner for Twitch, those are all hyperlinked there. So that free learning course is there, the learn.openshift.com is there, and the try.openshift.com is there. So boom, go to that page, scroll all the way to the bottom, hit those 3 banners.
Oh, you can see us live too. I just went there and
it's playing live. Yeah. The Twitch thing just picks us up automatically. It's pretty cool. And so next week, oh man. Not a good week for streaming. I'm gonna be honest with you. We've got so Red Hat is taking a day off on the 12th. I love this company so much. We're taking care of our people. We're gonna take a day off on next Friday. The 2 days prior to that, this whole team is gonna be in meetings. So we've got a lot going on.
Unfortunately, we actually do have a day job.
Yeah, so
in Hackfest.
And we have a Hackfest.
Yeah,
and we've got. So there's so much going on. What we're going to do, though, is we're going to keep expanding our efforts here, right? Like, we know that there's more people to reach. So we're talking like Periscope, we're talking LinkedIn, we're talking all these different platforms. Stick around. We're gonna be in where you want us to be. So have a great weekend. Christian, thank you. Amy, so much. Thank you. Really appreciate your time today.
Good hanging out with everyone.
Hit us up on Slack or Twitter or whatever. We're in the Kate's Slack. Everybody's everywhere kind of thing. So have a great weekend, everyone, and stay safe out there for real.
All right, everyone. Have a good
Take care, all.